Hey, hope that you're doing well. So in this video, we're going to be looking into 5 factors that affect your rate of reaction. Now remember, what exactly is your rate of reaction? This is the speed at which a chemical reaction is taking place. And now we're going to be looking into 5 factors that affect that speed. Now, the first one being concentration, right? Now, with regards to concentration, what happens to the speed of your reaction if you increase your concentration or decrease your concentration? Now let's start with increase. When you increase in concentration, it simply means that now you are making more particles to be present, right, in the same space. And now this would cause more frequent collisions between particles. As a result, this would increase the rate of your reaction, right? So now let me just write this here on the side. So when you increase concentration, what would happen is that you're going to increase the number of particles. And now, as a result of you increasing the number of particles, it means that now there are more particles available for reacting, right? Now, this would cause more frequent collisions between particles, right? This would cause more frequent collisions, and as a result, your rate of reaction would increase. The rate of reaction would increase, right? So increasing concentration increases the number of particles. As a result, more particles are there available for reacting, causing more frequent collisions between particles, and this would make the rate of your reaction to increase. Now, inversely, when you decrease concentration, it means that now you're reducing the number of particles which are available for reacting, right? This would cause less frequent collisions, and as a result, this would reduce the rate of your reaction. All right. Now, let us move on to the second factor, which is your catalyst, right? Now, remember, a catalyst is a substance that speeds up the reaction, right? It only speeds up the reaction and it doesn't form part of the reaction, right? Now, when you introduce your catalyst, what it does is that it lowers the activation energy, right? So it reduces the activation energy. Remember, what exactly is the activation energy? This is the minimum energy required for a reaction to take place, right? So let me just try to highlight this here, right? So it reduces the activation energy, which is the minimum energy required for a reaction to take place, right? Now, as a result, more particles would have enough energy to react, right? Because it doesn't mean that all particles have the same energy. There are different energy levels, right? And when the activation energy is reduced, which is the minimum energy required for a reaction to take place, this simply means that now more particles which didn't have enough energy before, they would now have the energy to form part of the reactions, right? As a result, this would increase the rate of your reaction. Now, if I can zoom in closer here into these graphs here, right? So this distance here, highlighted in green, this distance simply represents your activation energy, right? And now here in the second scenario, when we introduce a catalyst, can you see that now the distance is reduced, right? So the distance would be reduced, meaning that we have reduced the activation energy. All right. Now, what about division of state, which is the third factor we're going to be looking into? Now, division of state is simply changing from one state to another. For example, moving from a solid phase to a liquid phase, moving from a liquid phase to a gaseous phase. So basically, you are changing the state of your whatever compound that you are given, right? Now, when you are changing the state, let me make an example with regards to moving from a solid to a liquid. Now, in a solid phase, particles are compact, right? They are more closer to one another. Now, in a liquid phase, they're a little bit further from one another, right? They are not as close compared to solid. Now, what happens here is that when you move from your solid phase to a liquid phase, you're increasing the surface area. Now your particles have more space to move around, right? And as a result, this would lead to more collisions, right? So when you're moving from one state to another, in this instance, you're moving from a solid phase to a liquid phase. What would happen is that this would increase the surface area. And when you increase in the surface area, now more particles are exposed to react, right? More particles are exposed to react. Now, as a result, this would increase the number of collisions and increasing the rate of your reaction. Now, just to summarize that, so here, moving from a solid to a liquid phase, what happened is that we increase the surface area, or this would increase the surface area. And now, as a result, more particles are exposed to react, right? Are exposed to react. And now when more particles are exposed to react, this would increase the number of collisions. The number of collisions, and leading to your rate of reaction to increase. All right. Now, let us move on to the other one. So also here, right, inversely, so when you move from a liquid to a solid phase, it simply means that now you have reducing the surface area and now less particles are exposed to react. As a result, this would reduce the number of collisions, leading to your rate of reaction decreasing, right? Now, moving to the nature of reactants. Now, with regards to nature of reactants, what you need to know is that when it comes to nature of reactants, some are more, like some elements or compounds are more reactive than the others, right? So this simply means that they're going to react at a different speed than others, right? And this would be dependent on chemical properties. Now, let me make an example. Sodium dissolves, right? Sodium dissolves faster in water, right? So it dissolves faster in water. Now, what if I replace my sodium with calcium? Calcium won't dissolve as fast as sodium in water. So basically, me substituting my sodium with calcium, it would reduce the rate of my reaction, right? So your sodium, it dissolves faster than your calcium in water. So what you need to know with nature of reactant is that different elements or different compounds are going to react at different speeds, and this would be dependent on their chemical properties. All right. Now, the last one, temperature. Right. Now, temperature, what happens when you increase temperature or decrease temperature? How would that affect the speed of your reaction? Now, let's start off with when you're increasing the temperature. Now, when you're increasing the temperature here, it's going to increase the kinetic energy of the particles, right? So this is going to increase the kinetic energy of the particles, right? It's going to increase the kinetic energy of the particles. Now, your particles have more energy to move around. As a result, this would increase the number of collisions, right? So this would increasing the number of collisions, and not only increasing the number of collisions, but also the number of successful collisions, because not every collision would result in a reaction taking place. And why is that? As I've mentioned before, these particles have different energy levels, right? Hence, not every collision would result in a reaction taking place, right? Or in those particles forming part of the reaction, right? So here, when you increasing the number of collisions as a result of you increasing the energy, this would also increase the number of successful collisions per unit time, right? So increasing, right? And as a result, the rate of your reaction would increase, right? And inversely, when you decrease in the temperature, right, this would reduce the kinetic energy of the particles, right? Meaning that now your particles would have less energy to move around. As a result of them having less energy, this is going to decrease the number of collisions as well as the number of successful collisions per unit time, leading to your rate of reaction to decrease, right? So in a nutshell, these are the 5 factors that affect the rate of your reaction, right? And that will be the end of this video. Remember, if ever you have any questions, always feel free to reach out. Thanks.